So this one right here, it's a similar problem to what we just did. The only difference is now, instead of us setting our equation equal to 0, when we substitute our answer from this, we're going to actually set it equal to 2. So let's go through. Let's do that on the other page. All right. All right, let's clear some space out here. I'm going to drag that up. Okay. Okay. So what we got here, we're going to first set everything equal to 0. So not 0, 2. So let's go through. Let's do that. So everything in here is going to equal 2. And we're going to replace everything with 0 that we get from here. So that's really x plus 1 equals 0, which just means that when we subtract 1 from both sides, we end up getting x equaling negative 1. So that right there, that's what we got. Now, the next thing we're going to go through and plug negative 1 into all the x's that we see in this problem. So let's plug the negative 1 into all this, and let's simplify. All right, so we got 2 times negative 1 to the 4th power. We got negative 1 to the 3rd power. Then we got plus 2 times negative 1 to the 2nd power. And then finally, our last thing is we got k. So we don't know what k is yet, but we're going to find that out. So let's go through. Let's move this over a little bit. Okay. All right, now we're going to simplify this. So first off, negative 1 to the 4th power is just going to be 1 at the end of it, because then you take a negative number to an even power, it just turns it positive. So 1 times 2, this ends up turning into a 2. Now we got negative 1 to the 3rd power. That means that when we do this, we'll end up getting a negative 1. But since we got minus negative 1, what we end up here is with a plus 1. Now for here, we got negative 1 to the 2nd. Same thing happens here. This will end up turning into a positive 1. Positive 1 times 2 is just 2. So we got 2. And then we got minus k. That all equals 2. So we're going to take our like terms here. So we got 3 like terms. We're going to combine those. So 2 plus 1 plus 2. That ends up giving us a nice old 5. And then we minus it by k. And that all equals 2. So next, we got to subtract 5 to the other side. That cancels the 5's here, and that leaves me with negative k over here. Now 2 minus 5 ends up giving us a negative 3 to the other side. And if that's the case, if k equals negative 3, then that means that positive k equals positive 3. Now hopefully I don't goof up this time and we get this one right. So let's check. Let's put this 3. Let's hit this check. Alright, cool. We're good. Alright. This is the next one that we got. So this time they give me some polynomial, and they give me a couple polynomial answers for this. So what this says is we take this polynomial and we plug negative 2 in, we get 1. When we take the polynomial and plug negative 1 in, we get 3. If we take the polynomial, plug 1 in, we get 0. And if we plug 2 in, we get 4. Now, it asks you, what's the remainder of p of x when it's divided by negative 1? And then it's asking you for what's the remainder when p of x equals, x plus 2. Sorry. So, running this back. We're talking about the remainder theorem. So what this tells us is, in this case here, x minus 1 and x plus 2. These are the things we're dividing by, so let's take a look. So if we're dealing with this, let's get this. Oh, yeah, okay. When we do this, this is really what happens when we take x minus 1 and we set that equal to 0, which really gives us x equaling 1. So that's what happens where we're getting this 1 from inside of the problem. Now over here, same thing. We got x plus 2 equals 0, which just means that x equals negative 2. So they give us these two values here, our polynomial when we plug 1 in and when we plug negative 2 in. Now we see over here when we plug 1 in, we get 0. So that means that what's the remainder for this? This is going to be a big old 0. And then over here, the remainder when we plug x plus 2 in, that's what happens when we plug negative 2 in. We ended up getting a 1. So let's go through, let's check our math against what we got on Khan Academy. So I'm going to snap this to the right, I'm going to snap this to the left so we could check. Alright, so we got 0 here, and we got 1 right there, and let's check. Cool. So this time they'll give you the values that happen when you plug in the different x values that we get from solving the divisor. And then you just have to verify based off of what they give you here. Now, this one's going to be a little different. This time they give us a graph. So, we're going to go through. Let's take a look. Wait, does this have a drawing tool in here? Oh, snap. It does have a drawing tool. Alright, that's good. We're going to use this. Alright, so, what is the remainder of this polynomial when it is divided by x plus 1? Now, x plus 1 is really just simply what happens when we take x plus 1 and we set it equal to 0, which means that when we do this, it ends up giving us x equals negative 1. So what they're saying is what happens at this value. So here's negative 1 right here. What y value, what's the output that it points to when we're going to negative 1 on this little curve? So let's go up. We're going to go all the way up. In this case, it looks like when we're at negative 1, we are hitting positive 3 on the graph. So let's take a look. Does that make sense? That's what it looks like. Let's double check. There we go. Ooh, that clicked pretty quick. But yeah, that's simply what we're going to be doing for this one. Now that I see that this has a whiteboard function, I could just use this. Okay, let's look. Very last one.